Good morning, students. I'm your Nagini ma'am. Today, I'm going to discuss about the Van't Hoff factor. How to find Van't Hoff factor, students. This topic is from solutions lesson. Okay, Nama. So first of all, about the colligative properties, I will discuss, students. So colligative properties, we know that mainly depends on the number of solute particles. Yes, colligative properties mainly depends on the number of solute particles, but not on the nature of the solute particles. Clear this, students? So whenever solute undergoes dissociation or association, what will happen? There is a changes in the number of solute particles, hence colligative properties also changes. If suppose the solute undergoes dissociation, the number of particles increases, colligative property changes. If the solute undergoes association, the number of particles decreases, hence the colligative properties changes. Are you understood this one? Okay, so colligative properties mainly depends on the colligative properties colligative properties mainly depends on the number of solute particles, number of solute particles. Okay, number of solute particles, but not on the nature of the solute particles, nature of the solute particles. Clear this, students? Mainly depends on the number of solute particles, but not on the nature of the solute particles. Clear this, students? Okay, now when solute undergoes dissociation or association, what will happen? The number of particles changes, colligative properties also changes. Correct? If the solute undergoes association or dissociation. Clear? Association or dissociation, and if the solute undergoes association or dissociation in the solvent, okay na, in the solvent, what will happen, students? Number of particles changes. Correct? Okay, if suppose solute undergoes, number of particles changes, colligative properties also changes. Correct? Colligative properties also changes. Clear this, students? Okay, changes. See here, if suppose solute undergoes, if the solute undergoes dissociation, okay, dissociation, what will happen, students? If the solute undergoes dissociation, the number of particles, what will happen? Number of particles increases. So number of particles increases, what will happen, students? Colligative properties changes. Colligative properties changes. Okay, changes. If the solute undergoes association, okay, if the solute undergoes association, what will happen? Number of particles decreases. Correct? Number of particles decreases, hence colligative properties changes. Colligative properties changes. Understood, Nana? So colligative properties mainly depends on the number of solute particles, but not on the nature of the solute particles. If the solute undergoes association or dissociation in the solvent, then number of particles, okay, then the number of particles changes. Number of particles changes means colligative properties also changes. If the solute undergoes dissociation, the number of particles increases, colligative properties changes. Solute undergoes association, then the number of particles decreases, colligative properties changes. Are you following? So that's why Van't Hoff introduced a formula to calculate the colligative properties. Understanding? So that time Van't Hoff introduced one formula, students. Clear this one? So Van't Hoff introduced formula to calculate the colligative properties. To calculate the colligative properties, students. Okay, to calculate the colligative properties. So what is the formula, students? What is the formula? I is equal to formula what? I is equal to Van't Hoff factor. I is what, students? Van't Hoff factor. I is equal to total number of particles after dissociation. Total number of particles after dissociation or association or association divided by total number of particles before dissociation or association. Clear? Before dissociation or association. So this is the I formula, students. Van't Hoff factor. Okay, clear this? See, students, if suppose I am taking general equation AB, it is gives rise to A plus and B minus. That means AB is dissociate into ions A plus and B minus. Then what is the I value, students? How to find I value? What is I? Total number of particles after dissociation. After dissociation, how many particles are there? 1, 2. Correct? Total 2 particles are there here. Before dissociation, how many particles are participated? Only one particle, AB1. Here after dissociation, 1, 2, 2 particles are formed. Clear this one? So I is equal to total number of particles after dissociation or association divided by total number of particles before dissociation or association. This is undergoes dissociation, total 2 particles. After dissociation, before dissociation, 1 particle is there. So that's why we can write 2 by 1. I is equal to how much, students? I is equal to 2. Clear this one? Now see, students, I am taking here one equation, general equation. A gives rise to NB. Okay, A gives rise to NB. Now A is the, first of all, initially how many moles? A 1 mole. Here NB, how many moles, students? N moles. Okay, now N moles increases. So here this is 1 mole. Actually initially its concentration is maximum. This concentration is, it is 0 initially. So after some time its concentration is 1, its concentration is increased by N. Okay, now and after that I am taking the degree of dissociation alpha. So this product alpha increases. That means how much increases its concentration? Alpha increases. That means its concentration is decreases. How much? Minus alpha. Because we know that in every chemical reaction the concentration of the reactants decreases. That's why we have to take minus, and the product concentration is gradually increases. Correct? So that's why suppose alpha increase. Suppose here this is 100%, students, equation. This is the 100%, number of moles 100%. Initially here how much increase? Suppose 50% increased. That means 50% concentration of the reactant decreases kada. So alpha increased means, suppose the alpha is equal to 50%, it is alpha increases, and here how much decreases, students? Minus alpha. Clear this one? So here how much you have to take, students? Minus alpha decreases its concentration. Okay, now so that's why what we can write, students, at the equilibrium 1 minus alpha. Here 1 minus alpha, total concentration. Here how much, students? N into alpha. How much increases? N into alpha. This how much decreases, students? 1 minus alpha. So reactant concentration 1 minus alpha decreases, product concentration N into alpha increases, students. Are you following? N alpha increases. So then how to find the total number of moles, students? Total number of moles. How to calculate, students? 1 minus alpha plus N alpha. Correct? Both number of moles add 1 minus alpha plus N alpha. Then we can write 1 plus N alpha minus alpha. 1 plus alpha take common. Then N minus 1. Correct? Alpha into N minus 1. So what we can write, students? Total number of moles is equal to 1 plus alpha into N minus 1. Clear this one? Total number of moles. Okay, so then what we can write, students? Here I is equal to, okay, I is equal to total number of moles, so 1 plus alpha into N minus 1 divided by total number of moles of total particles before dissociation. How much, students? Here only 1 kada. So after dissociation, total number of moles, how much? 1 plus alpha into n minus 1 in this equation. Are you following? So in this equation, total number of moles is equal to 1 minus alpha plus n alpha, then this one. That means after dissociation, this many number of moles increases, students. Okay, 1 plus alpha into n minus 1 divided by before dissociation how much, students? Here 1 kada, only one particle is participated, 1 mole is participated in the reaction. Total number of particles here, this is the total number of moles. Are you understanding? This is the total number of moles. Here how many moles, students? Here reactant 1 mole kada, so you are taking 1 mole. Total number of moles, that is nothing but 1 minus alpha plus n alpha. Here you will get I is equal to 1 plus n minus 1 into alpha. So what we can write? I is equal to 1 plus n minus 1 into alpha. Clear this one? So I value we can calculate total number of moles by number of moles of the reactant, number of moles of the particle before the dissociation. Also we can take total number of moles, we can take by number of moles. Okay, number of moles of the component before the dissociation. So 1. So I is equal to 1 plus n minus 1 into alpha. Now how to find the how to calculate the Van't Hoff factor in the case of dissociation? Okay, now for dissociation, I'm going to discuss about the dissociation. Okay, so calculation of for dissociation, first I'm going to discuss for dissociation. Okay, in case of dissociation, students, what will happen? Dissociation, I is greater than 1, students. Okay, now for dissociation, I is greater than 1, because when the solute undergoes dissociation, number of solute particles increases kada. So the number of particles increases, then I is equal to number of particles, total number of particles after dissociation by before dissociation. After dissociation, number of particles increases, before dissociation less. That means more by less is equal to what we can write, students? It is more. I is equal to more. Are you following? So I is greater than 1. I is equal to what, students? More by less kada. I is equal to more by less. So that means I is greater than 1. Are you understanding? So I what is I formula? The number of particles after dissociation by total number of particles before dissociation. So when the solute undergoes dissociation, what will happen? The number of particles increases after dissociation more. That means the number of particles are more after dissociation. Before dissociation less. More by less. I is equal to more by less means I is equal to I value, it is greater than 1 kada. I is greater than 1. Clear this one, students? Right. Now I'm going to discuss in the case of strong electrolytes, students. In the case of strong electrolytes. Okay, in case of strong electrolyte, students. Okay, now I am taking suppose HCl. Okay, now strong electrolyte kada, HCl is strong acid. Okay, now it is a strong acid. If suppose we have to find the Van't Hoff factor for HCl, we have to find I value for HCl if 100% ionized. Okay, now if HCl 100% ionized. Okay, now ionized, then how to find the strong electrolytes I value? How to find it for strong electrolytes? See, students, I am taking the example HCl. We have to find the I value if HCl 100% ionized, because we know that strong electrolytes means the electrolytes which are undergoes complete ionization, correct? Completely ionized, that means 100% ionized. Strong electrolytes, correct? 100% ionized. 100% ionized means what, students? 100% ionized, that means 100 by 100. 100% means what, students? 100 by 100, that means is equal to 1. Are you following? 100 by 100. This is a degree of dissociation. Are you following? Degree of dissociation is equal to 1. 1 is equal to alpha. Are you understanding, students? 100% ionized. 100 by 100. How much? 1. It is equal to degree of dissociation. Are you following? Alpha value 1. So alpha value 1, we have to calculate how much percentage ionized. Suppose here 70% ionized, 70 by 100. Are you following? Then you will get the alpha value. That is the degree of ionization. Okay, degree of dissociation. Okay, so that is alpha value. Here 100% ionized given in the problem. So that's why we are calculating 100 by 100 is equal to 1 is equal to alpha. Clear? So now what is the formula, students? I is equal to 1 plus alpha into n minus 1. Correct? Here what is the formula, students? I is equal to 1 plus n minus 1 into alpha. we have to find I value kada. So calculate I is equal to 1 plus n minus 1 into alpha. Okay, n minus 1 into alpha. Then I is equal to 1 plus n value how much, students? N is what, students? Number of that means here number of particles. That means how to write, students? N value, number of particles increased. Okay, so that means n. See, students, what is n, students? Number of ions. Nana. N is equal to number of ions. Okay, number of ions. So that means here HCl, when HCl, it undergoes dissociation. What it produces, students? H plus Cl minus. How many ions are produced? 1, 2. Only 2 ions are produced. Clear this? That means n is equal to how much, students? N equal to 2. Okay, now 2 ions are produced. So n is equal to 2. Okay, minus 1 into alpha. What is the alpha value, students? Degree of dissociation, alpha value 1. Then you will get 1 plus 2 minus 1. 1 cancel. I is equal to how much, students? I equal to 2. Are you understanding? So I is equal to 2. Clear, Amma? So I is equal to 2. Actually, what is the formula, students? I is equal to total number of particles after dissociation by total number of particles before dissociation. Correct? So that means that also we can use directly formula. But here this much ionized, that much ionized here given now. So that's why we are calculating this formula using I is equal to 1 plus n minus 1 into alpha. Okay, Nama. So that means if I take I is equal to, what is the formula? Number of ions, number of particles after dissociation. After dissociation, how many particles? 2 particles. Before dissociation, how many particles? 1. Then I is equal to also 2. And I is equal to 2. 2 we got. Are you understood this problem? Strong electrolytes. Okay, so HCl is a strong electrolyte. I value, Van't Hoff factor we should find. If HCl is 100% ionized, then 100% ionized means 100 by 100, then we will get the degree of dissociation. Are you following? Degree of dissociation we have to find 100 by 100. If it is 70% ionized, 70 by 100, that is the alpha value. If 25% ionized, 25 by 100, that is the alpha value, degree of dissociation. Okay, like this you have to find Van't Hoff factor. In case of weak electrolytes, suppose in case of weak electrolyte, this is strong electrolytes, understood, Nana? Now I'm going to discuss weak electrolytes. Clear, students? In the case of weak electrolytes, how to take? See, weak electrolytes. In case of weak electrolyte, students, we have to find, suppose acetic acid given CH3COOH. This is a weak acid. Okay, now weak acid, Van't Hoff factor we should find, students. If acetic acid is 10% ionized, CH3COOH is 10% ionized. Ardhaitama. If it is 10%, it is a weak electrolyte kada. That means it is undergoes partial dissociation. It does not undergoes complete dissociation. So how much ionized? 10%. It is undergoes dissociation. Ionization how much? 10% given. Then how to find alpha value, students? 10% ionized means how to find it? Alpha 10% ionized. So that's why alpha is equal to, this is the question, students. We have to calculate solution. 10% ionized. So alpha is equal to how much, students? 10 by 100. Then you will get 1 by 10. 1 by 10 means 0.1. So the degree of dissociation is alpha is equal to 0.1. What is the formula? Alpha value we got. N is equal to how much, students? N is equal to how to find? So acetic acid, it undergoes dissociation, produces CH3COO minus plus H plus. That means how many ions are formed here? 2 ions. 1, 2. So that's why N value how much, students? N is equal to 2 ions. So N is equal to 2. Then what is the formula, students? I is equal to formula what? I is equal to 1 plus N minus 1 into alpha. Because this is also undergoes dissociation. Are you following? Acetic acid. In the case of dissociation, I am going to discuss, students. Okay, now I am discussing in the case of dissociation. For dissociation, okay, now for dissociation, we should use this formula. 1 plus alpha into, what is the formula, students? In dissociation, the case of dissociation, I value, I is equal to 1 plus n minus 1 into alpha. This formula we should use, okay, for dissociation. Clear? So then what you will get, students, here I is equal to 1 plus n minus 1 into alpha now. So I is equal to 1 plus n value how much, students? 2 minus 1 into alpha value 0.1. Are you understanding? So I is equal to 1 plus 0.1, then I is equal to 1.1 answer. I is equal to how much, students? 1.1. So this is in the case of dissociation. Are you understanding? So dissociation, that's here given HCl, it undergoes dissociation. How much ionized? 100% ionized. Acetic acid, it undergoes dissociation, 10% ionized. Are you following? So if it acetic acid 10% ionized means it is undergoing dissociation. Clear this one? So the 10% ionized means alpha degree of dissociation. This formula we should use, students. In this, n means number of ions formed, alpha is the degree of dissociation. Clear this one? Like this we should find. Now in the case of this is for dissociation. Now I'm going to discuss in the case of association. Okay, now see, students, for association, in the case of association, what will happen? Now I am taking the number of moles of A. Na gives rise to An. Now see, students, NaAN. Here number of moles N. Here number of moles I am taking as 1 mole. Here 1 mole only An is formed. Here n moles. Here 1 mole. Clear this one initially, and after some time what will happen? How much concentration of the product decreases, students? Alpha degree of dissociation, it is increases. How much decreases, students? Minus alpha. Are you following? It is decreased by minus alpha, it is increases alpha. Are you understanding, students? If it is 25% increased, that means it is 25. How much decreased? Minus 25. Here decreased. Reactant concentration. Are you following? Concentration, reactant concentration always gradually decreases. Product concentration gradually increases. Okay, na? So that's why it is alpha increases, minus alpha decreases. Now see, students, here n moles produces 1 mole. Okay, na? 1 mole of A produces how much, students? N moles produces 1 mole. 1 mole produces how many moles? Then how much, students? How many moles produces? 1 by n mole, correct? It is producing 1 mole. N moles of A produces 1 mole of A. 1 mole of N, that means 1 mole of A produces, N moles of A produces 1 mole. 1 mole of A produces, we have to calculate for 1 mole. Are you following? So 1 mole, this here n moles I am taking. Here 1 mole, n moles produces 1 mole, correct? 1 mole. I want to find for 1 mole. 1 mole of A produces how many moles of A? That means 1 by n mole, correct? Here I am taking, that is 1 by n mole. Here this is 1 by n mole. That means how much increased, students? 1 by n into alpha. Okay, now how much increased, students? It's concentration 1 by n into alpha. What about this one? How much decreased here? 1 minus alpha. For 1 mole, here how much decreased? Minus alpha kada? 1 minus alpha. Here how much increased? Alpha. And here for 1 mole we have to find. For 1 mole, are you understanding, students? For 1 mole, how many increased? 1 by n. So we have to multiply here. How much increased means 1 by n into alpha. How much decreased means 1 minus alpha. Are you following, students? This is 1 minus alpha. Now total number of moles calculate. Total number of moles is equal to 1 minus alpha plus 1 by n into alpha, correct? 1 minus alpha plus 1 by n into alpha. Then what we can write, students? 1 plus 1 by alpha take common, 1 by n minus 1, correct? So this is the formula, students. Total number of moles. Okay, now total number of moles, this is the formula. So 1 plus alpha into 1 minus n minus 1. So this is then what is the I, students? So how to find total number of moles by total number of moles of the product by how many moles of A that you have to take. So that means here 1 plus alpha into 1 by n minus 1 by 1. Are you understanding? So total here A component we calculated for 1 mole kada. So that's why we are taking in the denominator 1 mole. Okay, na? So the total number of moles here, how much increased here? Product side, that is 1 plus alpha into so we have to add total number of moles. Total number of moles by number of moles of the reactants you have to take. So 1 plus alpha into 1 minus 1 by 1. Understood, Amma? So in now this is the formula. I is equal to 1 plus 1 minus n minus 1 into alpha. This is in the case of association. Understood, students? In the case of association, this is the Van't Hoff factor, I value. Clear this one, I value. Now question is, see, question listens to, see students, so I is equal to 1 plus 1 minus 1 into alpha. This is in the case of association. Now see students, here problem. Now I am going to discuss the problem. See students, see students, so this is the problem. Acetic acid is dimerized in benzene up to 10%. Find Van't Hoff factor. Van't Hoff factor I value we should find. Dimerized means what students? Dimerized means it is forming the dimer. Acetic acid is undergoing association. Are you following? It is undergoing association. Dimer is formed. That means two molecules. Association. So number of molecules increases. Na? So that's it is dimer is formed. So that's what is the formula in the case of association. What is the formula students? I is equal to 1 plus 1 minus 1 into 1 by n minus 1 into alpha. So write that's formula students. Solution, I is equal to 1 plus 1 by n minus 1 into alpha, correct? So this formula right. And next, alpha value how much? Alpha is equal to how much given? Up to 10%. Dimerized in the benzene up to 10% given. So that's why 10 by 100. Then you will get 0.1 alpha value. And next, n value, how to find students? N value, acetic acid kada CH3COOH. It undergoes association, that is produces dimerized. Dimerized means what students? 2 moles. CH3COOH produces dimer. Are you following? Take here 2 moles. Understood? CH3COOH twice. Clear this one. 2 dimers, 2 molecules are formed. That means n value how much students? How many molecules are formed? 2 molecules are formed. Clear this one. So n is equal to 2. Acetic acid how many are formed? Dimer kada 2. That means in the case of ions, how many ions are formed? That we have to take in the case of dissociation. In the case of association, you have to take number of molecules. How many molecules are formed? N value. Okay na? So n value, n is equal to 2. Substitute in the formula. I is equal to 1 plus 1 by n, 1 by 2 minus 1 into alpha 0.1. Then I is equal to 1 plus 1 by 2 minus 1. How much students? 1 minus 2, that is minus 1 by 2. You will get minus 1 by 2 into 0.1. Then 1 plus minus 0.5 into 0.1 I value. So I is equal to 1 minus 0.05. Minus 0.5 into 0.1 minus 0.1 minus 0.05. Okay, then finally what you will get students? 1 minus 0.05, you will get 0.95. Are you understanding students? 0.95. Clear this one. So in the case of association, what is the I students? In the case of dissociation, I value is greater than 1 because more by less. Number of ions more kada after dissociation by less number of ions. That means more by less. Are you following? More by less means I is greater than 1. In the case of association, number of molecules less. Are you following? Number of molecules are less. Less. So that's why less by more. Then you will get the I is less than 1. Clear this one. I is less than 1. In the case of association. Understanding? It is I is less than 1. So this is the I value students. So less than. That's why 0.95 we got. It is I is less than 1. Clear? It is satisfied. So our problem is correct. Okay now. So finally what formulas we discussed students? What we discussed? I is equal to note. I is equal to 1 plus n minus 1 into alpha. This formula when we have to apply students in the case of dissociation. Okay na? In dissociation, I value greater than 1. Okay na? And next second formula. Okay, second formula is I is equal to 1 plus 1 minus 1 into alpha. This is in the case of association. Are you understanding? Association, that means I less than 1. Okay nama? I less than 1. This is in the case of electrolytes. Okay nama? Electrolytes. If suppose non-electrolytes we are taking. For non-electrolytes, I value is equal to 1. Okay na? Non-electrolytes. In the case of electrolytes, undergoes dissociation, association. Non-electrolytes means they will not undergo dissociation or association. So that's why I value is equal to 1. Are you following students? I is equal to 1. Okay. Thank you very much students. I hope you like this video. If you like this video, please like, share, comment and subscribe my channel students. Thank you students.